We are live. I'm going to wait for just less than a minute for more attendees to join in before we get started. I can see the attendee count going up. Okay. Hello, friends. Welcome to Be Waste Wise. I am Shweta Dandapani. I am one of the community builders on this platform. And we host 2 webinars every month on several topics related to waste and sustainability with moderators all over the world. Today we have Zoe Lenkovich, who has been moderating webinars with us for Be Waste Wise for a very long time, and she's also been a speaker on panels on Be Waste Wise for a very long time. Zoe is the director of Global Waste Lab. She's put together this panel to discuss 2 award-winning innovations which turn agricultural waste into clean energy and sustainable packaging. Zoe is going to talk to Ulugh Asimov, founder and CEO of Circular Bioenergy Technologies Limited, and Lahiru Vijayaratna, CEO of Modern Pack Lanka. A few housekeeping things many of you might already know. Please use the chat to introduce yourself so we know where you're from, and the speakers will also know what to talk about in this 1 hour. And please use Q&A for your questions. The questions are scheduled to be taken towards the end of the webinar, but if something is relevant during the conversations in the beginning, they might pick that up then and there. Over to you, Zoe.
Brilliant. Thanks so much, Sweta. And hi, everybody. Welcome. Lovely to see you all here. Hi, Gaboyega. Hi, Anna, Kirk, Neil. Good to see you all. So thank you very much for joining. I think we've got a very exciting webinar for you today, and it's a real honour and a delight to be able to introduce you to Lahiru Vijayaratna and Ulugh Asimov. So before I get into their, or give them a chance to introduce themselves and their incredible innovations, which are going to hopefully, or they're already taking the world by storm, actually. I'm just going to set the scene a little bit about the agricultural waste challenge. So, look, every year, vast amounts of agricultural waste are burned in fields, creating huge seasonal clouds of pollution. And from a circular economy perspective, what should be valuable biomass then becomes a big environmental liability. Now, the burning of agricultural waste releases greenhouse gases and black carbon into the atmosphere and has a serious negative impact on air quality, creating respiratory emergencies across entire regions. During burning seasons, millions of people suffer from pollution-related illnesses. It also represents a huge loss of opportunity because valuable organic matter is being destroyed when it could be creating economic value. And goodness knows many places could really benefit from that economic value. So this, I would say, is an incredible moment for change. These technology breakthroughs are making alternatives economically viable. The global urgency around climate and air quality is creating demand for these solutions. Farmers need profitable alternatives to burning the stubble in their fields, and today's speakers prove they exist. So, everybody, it's time to transform agricultural waste from a problem to an opportunity. So once again, welcome to you all. Great, we've got 26 people in the room already, and thank you for introducing yourselves in the chat. Really great to see you all here, so thank you for joining. Now, just before I introduce our first speaker, we've got a quick poll question. So heads up, Sweta's going to put a question onto your screens. Which is, before we dive into our innovations, let's understand your context. What's your biggest challenge with agricultural waste in your region? Okay, so we're going to ask you to just choose one. Is it the open burning regulations and enforcement? Is it a lack of economically viable alternatives? Is it limited awareness of conversion technologies? Or finally, is it insufficient infrastructure for collecting and processing? So really interested to hear what you think the main challenges in your area, what's holding us back from valorizing agricultural residues. Can everybody see that, the poll on your screen? We're going to close that in just a few more seconds. So let's see the results. How are we doing, Sweta?
All right, we still have people voting, so I'm just going to wait for a few more seconds before I
Okie
end the
dokie.
poll.
That's great. Nice to see that we've got people here from pretty much every continent as well. So fabulous. Oh, and quite a spread on the results. Okay, so we've got a third of you are saying regulations and enforcement is the biggest challenge. Only 7% identifying the lack of economically viable alternatives. And then another third each probably on limited awareness of conversion technologies and insufficient infrastructure. So there we go. Well, hopefully we shall be covering off all of those issues as we meet our speakers. So thank you for that participation. We'll have another question later on, so please stay tuned. So without further ado, I'm going to get to the interesting part that you're all here for, which is our guest speakers. So first of all, I would like to introduce Dr. Ulugbek Asimov, who is Associate Professor of Mechanical Engineering at Northumbria University and Chief Executive of Circular Bioenergy Technologies. And now Ulugbek has cracked the code on turning crop waste into clean energy storage. His biopower cell transforms agricultural residues into fully biodegradable batteries, winning multiple awards across the International Green Product Award. So welcome, Ulugbek. It's fabulous to have you here. Thank you for joining us today. So please, walk us through how crop residues are transformed into a functional battery. What is the key breakthrough that makes this possible?
Yes. Thank you, Zoe, and then everyone and audience. Before I jump into explaining how technology works and how we make these batteries, let me mention a few things first. So in 2024, in the UK, about 46% of electricity was generated from renewables. And then, so this is all together, all renewable technologies, solar, wind, hydro. So about 90% of that coming from wind power, right? So about 10 years ago, that number was about 16%. So 16% electricity was produced by wind. And you can see that in 10 years, it's been like more than double. And now what's happening is that the wind turbines, they are being shut down because the grid cannot cope with that, the electricity amount of electricity generated at peak times, right? So what happens is that those wind turbines are being shut down, and then to compensate, they switch on gas power plants, right? So this all together are costing UK government about 180,000 pounds per hour. Wow. So you can calculate, it will be billions per year. Well, someday more, someday less, but plus minus, it will be around that, right? So the missing link in here is energy storage, because we are able actually generate that much renewable energy, renewable electricity. And not only in the UK, I think around the world, the trend is same. But it's gone because we cannot store it. We cannot pump it into the grid immediately and use it, right? So then this is first thing, right? First idea. The second thing is that let's assume that we want to store all that renewable electricity, right? That produced around globally around the world. So we will need about 9,700 terawatt hours. That's total, right? So it will be roughly 26, 27 terawatt hours per day, right? And then if we compare that with the EV sector, which is also growing very fast, so EV would require about 2.5 terawatt hours. So you can see that it's 10 times So just imagine that, well, I'm talking specifically about battery energy storage, right? So the scale is enormous. So it will be huge scale, like large size of batteries we need to implement. And why batteries? Because they are very versatile, like flexible. You can install them anywhere. Like, for example, pump hydro, you need a landscape. Geothermal, you need specific area, specific location, right? But battery, you generate electricity, you directly store it, and then you release it, you use it whenever you need it, right? So thinking from that perspective, the scale and the amount, you can also imagine the amount of waste at the end of the life. All these batteries will come to the end of the life. So we need to do something with them, either recycle or do something. So at the moment, 10% batteries are being recycled around the world. In some countries more, in some countries less, right? So it's a huge problem. And then it will cost a lot of investment, infrastructure, and then also will cause environmental issues, because the recycling is not economically sustainable at the moment. It also environmentally damaging. So it's still process is not green. So coming from that perspective, our goal is that assuming that we will ensure that the battery that we produce, which will be biodegradable, green, right? If we ensure that it will operate within the same period of time as normal batteries, right? And at the end of the lifespan, we don't recycle them, but we biodegrade them, or we convert them into ionic fertilizer, right? So that huge amount of waste that we are talking about actually will be turned into product B, which is another value. And fertilizer, as you may know, is also very critical product for our life, basically. So now talking about how we make it, right? So we developed a process, we call it biofusion. So I just want to clarify that in our case, it's not only agricultural waste we can use. Any type of organic waste, which is fiber or powder form, is acceptable. So we put this waste into our biofusion process, and then we produce materials like at the normal pressure and temperature, which means that they are very cheap to produce. And then we produce the materials. So these are the samples. This is not the battery, but it's a sample of the material that we can produce. It's very strong, but the unique point of this material is that when you drop it into boiling water, it will be dissolved. And then it will be dissolved into fertilizer because of the specific composition and formula we have developed, right? So the idea is that we produce battery at the end of the lifespan. We just drop it, for example, the entire thing into the boiling water. It will be dissolved. There will be some metallic parts which are reusable, right? But most of this will be turned into product B, which is fertilizer. And then we can also control the composition. Like there are different types of fertilizers, like bespoke type, soil specific, crop specific, etc. So we can control that, right? So this is just a brief explanation. I will follow with further questions.
Wow. Thank you for that. I think I don't know if everybody else's mind is blown as much as mine is. It's such a cool invention. Really, really impressive. So and you're absolutely right. Thank you for raising the point about the battery waste, because that is a huge crisis. You know, even the small batteries that we're seeing now going into people's bins all the time, causing huge fires at waste facilities. And with this shift to, you know, electrical power, we're going to be relying more and more on batteries. So this is really, you know, one of the most timely inventions that I can imagine. Okay, so brilliant. So Ulugbek, what can you please sort of explain for us what's the key breakthrough that made this your invention possible, and how does the performance compare to conventional batteries?
So we have to be honest and realistic. There is no any battery that can beat lithium at the moment, because it's by nature. Lithium is the lightest element, is very active, it intercalates, and it compatible. So it's basically, and the development is going on. Lots of investment has been done, billions and billions, as you can see around, right? EV sector, etc. So we have to be honest and realistic. So we are not trying to compete, right? It's practically impossible with those technologies. So we are trying to bring alternative, right? And as I already explained. So in our case, we are very much limited by the number of materials and elements we can use, as you understand. So in our battery, we don't use lithium, we don't use cobalt, we don't use manganese, nickel, and any other rare earth or any other critical metals. So it's like I'll bring the analogy if it would be appropriate. If you are vegetarian or vegan, you cannot eat a certain type of food and products, right? But you still need to balance. You still need a protein, you still need carbohydrates, minerals, etc. So you need to balance your diet, right? And then you come to the work, and then you do the same amount of work. It's the same KPI as your non-vegan colleague, right? So you need to kind of debalance this and then operate within the resources you have, and then preferably perform the same level of work, right? Produce the same level of work. So in our case, it's a similar situation. So we are limited by type of materials we can use, right? But because these new technologies and then this artificial intelligence are coming, so we are actually very confident then we will be able to break this code through using these smart technologies and AI. But still, we cannot see that we will be at the same level as conventional lithium technologies, for example, right? So to give a number, for example, if lithium batteries energy density is around 150 watt-hour per kilogram, which I refer to LFP, for example, LFP time, our battery would be between 80 and 100. So it's lower, but as I explained, if you think about environmental impact and then the scale, right? It can bring and the availability of the materials that we produce. So we don't need to mine those expensive metals. As I explained, we just get organic waste and we produce battery from the organic waste.
Yes. Thank you. I think it's just incredible. And, the more that I listen to you, the more I realize how many other big problems this solves. For example, with the mining, the human rights abuses in mines, plus the huge environmental damage from mining, anything that we can do to move society away from needing those rare earth minerals and metals is going to be a benefit. And, agricultural waste is widely abundant all over the world. So do you see what's your vision then at Ulugbek? Do you see like a network of factories around the world that are close to agricultural areas that are able to produce these batteries?
Correct. If you look at these gigafactories, like conventional batteries, like lithium based, etc., they are very expensive. I mean, the reason for that is they require specific environment, like vacuum, inert atmosphere, argon, nitrogen, etc. Right? So very high precision, etc. In our case, we don't need this type of environment. So the idea is that you can deploy a factory, like average, even larger scale factory in some rural area, and then since if the supply chain is established in terms of waste, materials are coming, right? And then further, how it can be distributed on the market, that easily can be like thought of, the developing this infrastructure. within somewhere in the even rural areas, and then also help farmers. For example, they automatically may become a suppliers of that all the waste they generate and burn sometimes, most of the time. Yeah, and but instead it could be used in this through this channel and then produce batteries, energy storage systems.
Fabulous. Fabulous. Okay, great. And I want to say thank you to Neil Petken, who's put the first question in the Q&A. So Ulugh, perhaps if you could just clarify this one for us, and then we'll look to wrap up with this introduction. So over to you. What is the active chemical ingredient?
So the question is that what's active chemical ingredient? Sodium. No, it is not sodium. Well, unfortunately, I cannot disclose this now because we are going through a patenting process at the moment. But as I mentioned, it's not lithium, it's not cobalt, it's not manganese, it's not sodium, it's not any other those rare materials that use in conventional batteries.
Fabulous. So something that is presumably widely available in agricultural waste.
Yes.
And yeah, I mean, I can really just, you know, the value of this, the more I think about it, the more expansive that value becomes on so many different levels, that it's yeah, really exciting. And I'm sure that all of our
I just want to emphasize that we are restricted. We are restricted what we are doing because the goal is that to produce or to repurpose the battery waste into fertilizer. So we also need the material, specific material that could be used as a fertilizer, preferably without any further processing, because it will add another cost and things. So as direct as possible, right? So we are trying to look at this direction and that scope. So that's why we cannot use any of those materials that you cannot put straight into the soil.
Yeah, that makes sense. No, the perfect renewable energy battery for a circular bioeconomy. I love it. Brilliant.
Yes.
Thank you very much, Ulugh. And you know, audience, please do remember to pop your questions in the Q&A if you have any. And as you've just seen, we will do our best to respond to those. So thank you, Ulugh, for sharing your innovation with us. We will come back to you later on. But for now, I would like to hand over to Lahiru Wijeratne. Welcome, Lahiru. So Lahiru is the Chief Executive of Modern Pack Lanka, which has developed a process to transform rice straw into a globally recognized sustainable packaging material. And they recently won the prestigious World Star Packaging Award, which is, you know, seriously a very, very high honor. So hi, Lahiru. You and I met on a beach litter pick in Colombo some years back, and we've kept in touch. And so it's really, really great to be able to invite you here today to share your latest innovation with us. So please go ahead, give us your background and tell us a bit about your new packaging innovation.
Yes, thank you very much. So, it's nice to meet you after 4 years through a webinar. And so I'm from Sri Lanka. So we have 22 million of population, and interestingly, 30% of our population are farmers. So they are depending on farming, so agriculture. And our main main food is actually rice, and so there's huge cultivation in Sri Lanka, and so our annual rice production is 4.5 million metric tons. 4.5 million. And so in that case, the generation of rice straw is it's approximately 6.75 million metric tons. So that's huge. And so then when it comes to corn, so we produce 300,000 metric tons, and the residue is also in similar range. And so altogether, the two of the main agriculture residues, so it close up to 7 million metric tons. So what we thought is because we are in the process of coming up with sustainable solutions for packaging. And so we don't believe in paper as a sustainable packaging product because to make paper, you have to cut down trees and intentionally, so there are harvested forests. But so in that case, we don't believe in paper. So we wanted to turn something that is wasted at the moment. So in our country, so we have seen this. So we have abundant amount of rice straw and corn husk, and approximately 7 million metric tons, 7 million metric tons. And so we thought of developing a formula to turn this into packaging without going ahead with paper packaging. Then we work with Sri Lanka Slimtech. So that's the nanotechnological institute in Sri Lanka. So we work together because so my company, we have the engineering expertise. So we have the expertise in developing molds and in the packaging. So we were able to turn this into a tangible product very fast, and so we were successful. So not only food packaging, so we have successfully turned this into items like this. So we'll be seeing. So this is a hanger. So we have developed this for famous UK-based international brand. So I cannot disclose the brand, but so this packaging, this is a box. So we have developed to replace cardboard box, and this is made of rice straw. And so the concept was so we had abundant amount of agricultural waste that is wasted, and it's full of cellulose and lignin. So that was the main idea. So we wanted to come up with a truly sustainable packaging solution.
Brilliant, thank you. I think it's absolutely fantastic. As you were talking, I was just remembering all of that plastic packaging on the beach that we were dealing with in Sri Lanka, and so it's really great that you've used your career to really try to address that from a systemic level and provide these alternatives, again, not made from cutting down trees, but from a waste that's widely abundant in Sri Lanka and many other regions. So it's fantastic. And now, look, Lahiro, I know that the packaging sector itself it's a very established sector. It can be very difficult to bring in a new invention or development, and get it widely taken up. So in terms of your positioning in the market then, compared to conventional packaging, where do you see I mean, clearly your main strengths are the environmental story, but would you like to just, explain for us how you are positioning your packaging within the packaging market?
Yes, so usually the challenge is these sustainable innovations or biodegradable packaging or alternatives. The cost is usually high.
Mm.
So that was the very fact we wanted to attack, and so that's why we have found a solution because our raw material is almost free of charge because otherwise it's burnt. Uh, so we have enough or more raw materials, but we have a model where we are paying. Uh, but so you mentioned something very important, the economic value, because when we consider anything that we produce intentionally, it can be a product, it can be a crop. So we have invested a lot of effort, energy, and so there's a carbon footprint that is inbuilt in every product. So even in this agricultural waste, so there's a huge carbon footprint that is inbuilt. So we saw it as a huge economic value is there, and we wanted to extract that. So that was the main idea. And in terms of positioning and competing with the conventional packaging, so we can actually we have done the costing and pricing. So we can the price will be slightly less than the conventional packaging. So that will be the best news. And so this is purely entirely biodegradable, 100% biodegradable. And the other thing is, let's say if we are burning this entire crop, so the amount of carbon dioxide and methane emissions will be enormous in terms of millions. But so we have found a solution where, and let's say if I give you a figure, okay, out of 7 million metric tons, let's assume that if you can utilize 30% of these agricultural waste, that's about 2 million metric tons. If the weight of these packaging is approximately 50 grams, so that means we can produce 50 billion pieces. So even if we use 30%, so we can produce 50 billion pieces. So that means this is huge, enormous, and it's scalable. So then with that, I think we can easily compete with the conventional packaging. But I have to accept there are some challenges in terms of depth of some of the packaging. So there's a limitation. So there's a maximum level where we can go, and every shape, it's not possible to achieve with this technology. So we have to use a kind of a thermoforming. But so whatever possible, so we try to achieve, and the main intention is we will not go behind the generic products. So we want to do products with value addition, like some maybe hangers for apparel industry, because Sri Lanka is very famous for apparel, and packaging for tea, packaging for liquor. So likewise, so we will be innovating uh, and try new stuff because we have abundant amount of raw materials.
Brilliant. Okay, thank you, Lahiro. It's yeah, again, really interesting. Just listening to you, and my mind's going to all of the different potential applications that your packaging could be used for. And I totally hear you that, I mean, there isn't a single kind of packaging that can be used for everything. Whatever material you use, it still has its limitations or needs certain additives or different processes and so on to make it appropriate for different applications. But just listening to you working out the numbers there, that just from the the rice and corn waste in Sri Lanka being able to make 50 billion pieces, so that's potentially 50 billion pieces of plastic waste that aren't going to be generated, or the trees that aren't going to be cut down because we're able to use this widely abundant agricultural residue is yeah, just hugely impactful. So congratulations on that. I'm very excited. Okay, so recently, like, you won the World Star Award, which is awesome. So did you get kind of feedback from the judges on what it was that they really loved about your innovation? And since you've won that award, how has the recognition impacted your scaling efforts? Has the phone not stopped ringing?
Okay, yeah. So in May, we won the World Star Award in Manila, Italy. So this was conducted by World Packaging Organization. So over 100 countries competed, and we were fortunate enough to win this in terms of the sustainability aspect. And so the feedback we got, as well as the points we pitched, were mainly so the first aspect was the impact what we can bring to reduce the air pollution by burning these openly. So that's a huge saving, because we can save a lot of CO2 emissions, as well as the methane emissions, if we let it degrade on its own. And the second aspect was reducing the amount of plastics that is added or accumulated in the environment by replacing whatever possible packaging through completely degradable material. So that was the second aspect. And the third aspect was the social aspect, because this is something that is wasted or burned uh, by the farmers once they harvest their crops. And so we are paying 20 to 30 rupees per kg. And so we will have kind of because the rural income, there will be a rural income generation through this model. And so in the previous calculation, I have taken 30% approximately in calculating the number of pieces we can produce. But let's say even we take only 10% of wasted agricultural waste. So even if we pay 20 rupees, so that will be approximately 4 billion rupees that is circulated among the rural farmers. And in fact, I would like to remind that I started the explanation saying 30% of our population, they are relying on agriculture, and 2 million farmers are there in Sri Lanka. So these are the three main pillars that the judges had taken into consideration when judging our innovation.
Yeah, great. And that is true sustainability, isn't it? The social, the environmental, and the economic dimensions all there in one set of products. So yeah, fabulous. Thank you. Really great to hear, and I hope that the audience are still with us and enjoying hearing about these innovations. So I have a quick couple of questions for both of you. So perhaps Lahiri, you can have a moment's breath, and I'll go first to Ulugbek. But same question for you both, please. So you're both working to replace open burning, with value creation. Now, what role do government policies play in supporting or hindering adoption of your technologies? Ulugbek.
There are plenty of like regulations and laws. Well, I will speak about UK only, because I look at these regulations. So there are so many incentives, and then the support. First thing is the grant money funding. So we have this Innovate UK. We have some other government bodies which can sponsor or provide some amount of money for research and development, and then also the market research, and then product development, etc. There are some regulations. For example, you may heard about battery passport. So it's not only UK, it's basically going to be globally. So the same as every human has a passport, and then with that we know where the human is living and where he's going, etc. So it will be same thing about battery. So where the battery was produced, from which source, right? What is the first life, second life, etc. So all this will be monitored, and then certain requirements will be put on manufacturers, right? So there may be a situation that EU may say to, for example, foreign supplier, that your battery should have 30% of materials recycled from previous cycle, right? Or it should be 20% biodegradable. So this will put a lot of pressure on manufacturers, but also will control. So whoever reach those objectives obviously will win. So apart from that, there are other like standards and regulations. But talking about our technology, because it's very different from conventional one, because for conventional one there's some recycling standards and then regulation, etc. In our case, it's a kind of new. So that's why it's a challenge, and on the other hand, it's actually opportunity for us, because we can set a new standards. So we can set the new standards, what should be the way to go. And then I'm sure in few years the new teams will appear which will create something even more exciting, even better, etc. So that will grow. But these are all at the moment with the support. UK government goal is that sustainability net zero by 2050. So these are all kind of aligned very well what we are doing with the government policies.
Great, thank you. And I'm sure that lots of governments around the world will be very interested. You know, if you're going to be typically importing a lot of batteries every year, it's going to be far, far, far more preferable to be importing batteries like yours that can, you know, be dissolved into fertilizer at the end of use, rather than creating, you know, huge hazards potentially in dump sites, causing explosions, you know, leaking battery acid into groundwater systems and so on. So yeah, I can totally see how you are actually raising the bar. You're creating a new standard that others will in the future will have to meet or try to surpass. So yeah, fantastic, moving the dial there.
I just want to add a few things. So the main challenge is the scalability. So Lahir also mentioned that's the valley of death, right? So for many startups and new companies, so scalability is not only in our case, is a size. It's not only that we want to build bigger battery, right? It's first of all competitive price, like cost competitiveness, sustainability, right? And then obviously the investment that we can get to expand, to build those factories, small, average, larger scale, and etc. So that's the very critical moment. So whoever will be able to scale into that required level will basically win the game. So it's a huge challenge, but because we have these regulations and laws, they allow us to get these instruments, you know, and put them together, and then, you know, move further to develop this technology.
Yeah, okay. And do you feel that the UK focus on net zero at the moment has been a really big, you know, giving you a good advantage there, compared to perhaps if there are other research teams in countries where the government isn't incentivizing it so much?
Yeah, I mean, you can see on TV, on BBC, and discussions a lot. Everything is about net zero. There are different opinions about that, whether this is the right way to go or not. But in general, I think that's we will get there sooner or later. So we need to start working now. We need to doing these things now in order to be there in, I don't know, 20 years, 40 years or further. We'll see. But this is the only way forward. That's why since everyone is talking about these programs, new regulations are coming every year to support these innovative startups and ideas and technologies. So I'm sure that it will further grow, even further grow, and we will get support. Yes.
Yeah. Yeah, excellent. Okay, thanks, Ulugh. Lahiru, how about you? And what role do government policies play in supporting or hindering the adoption of your sustainable packaging?
Actually, in our country, there are a few regulations coming up in terms of promoting sustainable or degradable packaging, and they have banned lunch sheets, and they have banned shopping bags below a certain thickness, and they have banned plastic straws. And so these regulations will promote sustainable packaging. But so as I earlier explained, I don't see paper as a sustainable alternative. So it has to be truly sustainable, or it should have a meaning. And in terms of implementing loan schemes, so then the governments can support initiatives where it protects environment and prevents air pollution. So if they can support entrepreneurs through that type of schemes, so that will definitely be supportive. And so as partly answering your third question that was raised previously, so we got attention. So we got the attention of USAID as well as some other European agencies as well. But unfortunately, USAID, the things didn't go in the right way. So it was almost okay. Uh, but honestly, so there are a few agencies that they are really interested with our innovation, and so they are trying to support us because it has. So what they mentioned is it has ticked all the relevant boxes, not only the sustainability aspect, and it had addressed the social aspects as well as preventing the pollution and utilizing whatever the economic value of uh, the the crops what we have developed and we have invested and already invested the carbon footprint there. So these are the areas what comes to my mind at the moment.
Yeah, no, that's fabulous, Lahiro. Thank you. While I was listening to you then, I was also thinking about how if farmers' income can be raised and they can have better, more sustainable livelihoods. So we're not just raising their income, but we're also providing diversification of income, right? So where, food prices might go up and down, and it can make or break their sort of annual finances. But if you're providing a secondary stream of income, then that's going to be providing them, the farmers themselves, with much more economic resilience, which in turn then takes the pressure off a little bit in terms of people moving to cities, right? Because that rapid urbanization that we've experienced in the last few decades puts an enormous pressure on the environment, on all sorts of things, trying to get produce from the farm into large cities in a way where it's not going to perish before it gets to the consumer and so on. So all of these big problems that we have from urbanization because of rural incomes being so low and people feeling that pull to the city. So yeah, just the more I listen to you both, the more benefits I'm spotting in both of your innovations. So really exciting. Right. Look, we've got just over 10 minutes left. So I'm going to go back to the audience. I hope you are all enjoying it. If you're enjoying this discussion, let's just give us a thumbs up or a yes in the chat bar. And then we're going to go to our second poll question. Great, thanks, Anna. Glad you're enjoying it. So the second poll question that we have, here we are. Thank you, Sweta, for putting that up on everybody's screens. So in terms of the organisations that you are here representing today, great, thank you. We've got some really nice feedback coming in the chat there. Thanks everyone. Gaboyega, Obina, Dana, thank you, Fazuk. Great to see you all here. So back to this poll question. What's your primary interest in agricultural waste solutions? Okay, and we can pick more than one here, can't we, Sweta? Is this the one? Yes.
You can
okay,
pick more than one.
Lovely, thank you. So you'll be glad to know you can pick more than one. Is it the improvements in air quality? Is it the climate and carbon reduction goals? Is it the development of circular bioeconomy and or the economic opportunities for farmers? And maybe I should have added other, because I'm sure, as my mind's been working, all of these different, multiple benefits that are just kind of stacking up on top of each other are coming into my mind. So please go ahead and select as many as you think are fitting. And here we go. Great. Okay, so circular economy came out top at 73% of you have identified circular economy, shortly followed by the climate goals, and then also the economic opportunities for farmers and air quality improvement. That's a quarter of you each as well. So yeah, really good spread here. And I think, it just shows, well, maybe it's the audience that we attract on the Be Waste Wise webinars. So it doesn't surprise me that circular economy and climate impact are top priorities there. So super, thank you very much. We have a question here from Artie. in the Q&A. Thanks, Artie, for adding your question here. Okay, so the question is, I presume for Lahiru, how are you able to balance the revenues to farmers versus the costs of the products from agricultural residues, for example, energy, which may be used by the same farmers? So if I can have a go at rewording that. So if the farmers are currently utilizing their residues for energy production on site, is the fee that you would pay to them for those residues to make your packaging, is that competitive? Would that help tip the balance to get them providing their residues to you rather than using it for perhaps on-site energy production?
No, actually. So they are not using it for energy as an energy source. But so what? A part of these waste is used as a fertilizer, because what they do is, because in Sri Lanka the rice cultivation, so there are two major seasons. So after the first season, so some of these residue is kept inside the field and let it degrade on its own, where the nutritions, so it will absorb again to the soil. But so that's why we have taken only 30% of the residue, because so we are not going to take entire waste or entire residue. So that will be huge. So I don't think we owe entire country we can handle that, because as I explained, even 30% will be enough to produce 20 billion pieces of this. This is actually only 20 grams. So
It's tricky with the effect, the background effects. Yeah, we're just getting glimpsing it from time to time. Yeah, got it.
Yeah.
Thank you. Perfect.
Okay.
Perfect.
So it's only 20 grams, but we have bigger versions as well. So 50 gram, whatever the packaging, so you can produce 20 billion. So because of that, I'm very sure so we can balance, and even after producing, there will be a lot to manage, and so someone else has to come up with some other innovation to handle that part, I think.
Yeah, yeah, absolutely. So you're literally providing a solution for a waste stream that is literally just sitting there waiting to be burned, or it's going to rot and potentially generate methane. Either way, not good for the atmosphere, the climate, air quality, and so on. So yeah, it's a real win-win-win, and particularly providing that extra revenue for farmers, as we discussed. Okay, fabulous. So look, guys, we are into the last almost 5 minutes. So I've got a couple of questions lined up for our speakers. If anybody in the audience has a question, now is the time to pop it across in the Q&A. But for now, I'm going to ask Ulugh, if I may. So in terms of the key stakeholders that you are wanting to engage with to really, allow your innovation to reach its potential. So at the stage that you are at now, which is potentially, the beginning of the valley of death, as you've built up, you've got a great product, you can see its potential, but then scaling up your business so that it can become, a successful growing business, 10, 15, 20 years into the future. What are those key partnerships and key stakeholders that you really want to be engaging with and having these very important conversations right now?
So there are two directions. One is that it's all about supply chain. So one side is suppliers of those organic materials and waste. Even though we say waste, it's not just there available, right? So talking about sources. So you mentioned agriculture waste, but talking about UK, within the UK, we've done some research already. So it's about 20 million tons of, I think, the agriculture waste produced in the UK, but the largest waste producer is brewery. brewery technologies. So they produce. If we look at the globally, I think it's around 100 million tons of brewery, just the beer, right? Beer industry.
Yeah.
So for us, as I mentioned, it's just the fiber and the powder is sufficient. So that is one of the candidate, for the supply chain, because thinking about, again, scalability and large scale. But we are considering different channels. That's the important part. The supply of raw materials, important. The second part is distribution. So if we are making our battery, and then as I mentioned, the final goal is the large scale, right? But before we go there, we're actually considering step-by-step development. So first would be residential energy storage. So instead of like 40 feet container, which would give you around 2.5, 3 megawatt hour, we are looking at something smaller, like let's say like 10 kilowatt hour residential storage, or like it still can be industrial, but a smaller scale, right? So distribution channel, B2B or B2C, right? And then what would be the business model? For example, we are considering the energy storage as a service, which may involve subscription fee, and then capex light option for the consumers, right? So because technology is new, so we bring the battery, we install it, we maintain it, we replace it, we turn it into fertilizer, etc. So this is one type of model. The other, supplying direct final product, and then the different levels, as I mentioned. But the final one is the larger scale for energy storage. So putting these two on the scale, balancing, in my opinion, that's the most important part, because in terms of skills, we can train people, we can teach them about technology. This can be done, but to make supply and distribution sustainable, that's the key for us for scaling up, and then to avoid that period of the valley of death region.
Yeah. Brilliant. Thank you. Thanks very much, Ulugh. And Lahiru, over to you then, in terms of your, the conversations, the people you want to be getting your innovation in front of. Who's top of your wish list?
We didn't get the last part, sorry.
Sorry, who is top of your wish list, to really help grow and scale your innovation? Are there key stakeholder groups or specific types of organizations that you believe that if you could get this innovation, in front of them and show them the potential, that it's going to really help you scale rapidly?
Okay. So there are actually, so I must say, so we can scale these up with our own funds. So so it's not that nice to trouble any party in terms of that. But what we want is more connections, and with our engineering know-how, so we can design this not only to one product, but based on any product, we can do the molding, we can change the formula according to the requirement, and we can do customized products. So with that, if if you are in the process of making your packaging sustainable, and if you are looking for better alternatives, please reach to us. If you are a consumer or if you are a manufacturer, so we would like to see whether we can provide you some packaging through Sri Lankan agricultural waste.
Fabulous. So happy to export as well, because that was one of the questions here. Dana has put in the Q&A. Thanks, Dana. Is the market for sustainable packaging in Sri Lanka mature enough to be your target market, or would you be looking to export?
Yeah, exactly. Because that's why I emphasize in one of the previous questions, because we will not go behind the generic products, because that will not be sufficient to make this a viable business, because it's still a niche. So we want to keep on adding value and we would like to go after value-added products. customized products.
Yeah, brilliant. Okay, thank you very much. And there's just one other question here. We're going to wrap up now. Salamatu has asked about, whether these innovations will be, will small scale businesses be able to be producing these kinds of products in the future, maybe in Africa and elsewhere. Well, I would, I'm going to guess here. Maybe I can just get a nod from the speakers, but I would say it's a bit early for that yet. You need to prove it as a successful business model, and then you might be looking to franchise or scale out. I mean, is that about right?
Yes, so that's possible because so we have two phases in our plan. The first phase is to produce the packaging on our own, and the second part is so we will put a facility where we will turn these waste pulp into a kind of a mixture, and we will dry it, and we will export it where you can just add that amount of water, and you can use it. So that's the second part. Not only water, so there are a few add-ons as well. So that's the second phase.
Real, great. Okay, so thank you so much. We're gonna have to stop here because I know that people are scheduled to be elsewhere, but this has been such an interesting conversation. Thank you both hugely for giving your time, sharing your really, really impressive innovations. And are we going to be, oh yes, good, thank you. Sweta has dropped all of our LinkedIn links there in the chat. So please do connect with us online and continue the conversation. Thank you all very, very much for joining us, and huge round of applause please to Ulugbek and Lahiru. You can all you can't turn your microphones on, but I can tell you're doing it anyway. So thank you guys, and Sweta, back over to you. Thanks for all the organizing.
Thanks.
Thank you, Zoe, Lahiru, and Ulugbek.
Thank you, Dr.
Thank you for organizing. Yeah.
Thanks,
before we wrap this up, I just want to remind everyone that Lahiru's team are organizing the biggest beach cleanup in Sri Lanka. It's on July 20th, right, Lahiru? What's the date?
26th July at
26th.
Crow Island Beach. At
Crow Island Beach, we will put up the details of it on the Be Waste Wise LinkedIn page. Please feel free to please have a look at it. If you know someone in Sri Lanka, please send it out. And thanks a lot, all of you, for your time. It was a fantastic webinar. The webinar will be recorded and available on our website in 2 weeks' time.
Great.
Bye-bye.
Thank
Thanks
you.
so
Bye.
much. Thanks,
Thank you.
Ulugbek.
Bye-bye.
Thanks, Lahiru. Thanks, Sweta. Thank you, everybody, for joining. Great questions.